All right, let's talk about your work from part 2. For number 1, we've got contradictory statements. That means that the truth values underneath the main operators of these two statements are exactly the opposite on each line. When one is true, the other is false. And when one is false, the other is true. And we can see that, for example, on line 1, our first statement is false, and the second statement is true. And on line 2, the first statement is true, and the second statement is false. And it follows that pattern of opposite truth values all the way down to the bottom, making these statements contradictory. Now, a really important thing to keep in mind when you're using truth tables to compare statements is that the truth values underneath your individual letters have to match every time that letter appears. So we can see here, when we used L equals 2 to the n to construct our first truth table, we wound up with 2 T's followed by 2 F's underneath H. And those truth values have to repeat in that pattern every time H appears, because each line on these truth tables represents a particular moment in time, and we know that a given statement can't be both true and false at the same time. So you want to make sure that the truth values underneath your letters match exactly every time those letters appear. A really common mistake that folks make when they're using truth tables to compare statements is that they'll use L equals 2 to the n to construct the truth table for the first statement, and then they'll start over and use L equals 2 to the n to construct the truth values for their second statement. And then you're going to wind up with truth tables that aren't reliable. Okay, so you just make sure that your truth values underneath individual letters match every time the letter appears. For number 2, we've got consistent statements. That means that these statements are both true on at least one line. For example, line 1, both of these statements are true. The truth values don't match exactly on every line, so these statements aren't logically equivalent, but we can see that there's a number of lines, like lines 1 and 3 and 4 and 5, where both of these statements are true at the same time, and that tells us these statements are consistent. And then finally, we've got a couple of inconsistent statements. And what that means is that we might find lines where both statements are false at the same time, but we're never going to find a line in these truth tables where both statements are true. It's not possible for both of these statements to be true at any given time. And that means that these statements are inconsistent.